Hello. So today I would like to go over finding the sum of numbers, but instead of going from 1 to 10, what if we started at 3 and went to 10? Now, as you recall before, we did it with basically what's called the rainbow method. And we found that if we connected the first and the last one, get the, in this case, we get the sum of 13. And if we keep moving in, we get the same sum. So just as before, if we started with 1, our common sum was 1 plus the number. But in this case, our common sum is going to be the first number, which is 3, plus the last number, which is 10. And that stays the same as we move in from both ends. On one side, we're increasing by 1. On the other side, we're decreasing by 1. So yes, not starting from 1 doesn't affect the common sum. And just as a point, so then the other part though is finding the number of terms. Now finding the number of terms when you start from 1 and you count all the numbers, it's just going to be the number of numbers. But in this case, we didn't start from 1, we started from 3. So one way to get the number of terms, which I notate with an N, would be to say, well, if we had started from 1, then we would have 10 terms. Let's take off the terms we didn't count, which are 2. Another way to do it is to, which will be more useful later when we do skip counting, is to take the last term minus the first term. And what that tells you is it tells you how far it is from the first term to the last term. But this excludes the first term. So you have to add 1 in for that first term. 10 minus 3 is 7 plus 1 is 8. So you get 8 that way also. We gotta move on this board. Not making you dizzy. Okay, so so our sum here is going to be 13. It's going to be total sum is the common sum times the number of terms divided by 2, half the number of terms. So it's going to be 13 times 4 or 52. And we can see the 4 13s in the picture. Again, using a smaller example like this should make it easier to do a bigger one where we can't see all the rings. So now let's look at what if we add another thing to this. Actually, let me give you a formula for this. Yeah, we'll get a more general formula later. So now, what if we start at 3 this time? This time, we skip count. Maybe we'll count by add 4 each time. 3 plus 4 is going to be 7. 11, 15. Let's do that. I'm going to put this down here. 3 plus 7 plus 11 plus 15 plus 19 plus 23. Now the main thing is that this is what we call an arithmetic sequence. each time I'm adding up by the same amount. We still have the same characteristic that the first and the last, 26 in this case, and as you go in, the sum will always be the same. So we still maintain the common sum. Common sum is still the first plus the last, but I'm going to give you a little more terminology just to make it a little easier. I know sometimes I call it F plus L, but I'm going to give you the sequence terminology. The first term is usually notated A sub 1, and then 2, 3, 4. This would be A sub 2, A sub 3, A sub 4, A sub 4, and A sub 6. So A sub 6 means the sixth term, the sixth number. Our common sum is going to be the first one. Now I could write A sub 6 if there are 6 terms, but if I just want to generalize it, I'm going to do A sub n, meaning the last term. So our common sum is the first term plus the last term. That stays the same for all of these sums of numbers. That stays the same. What gets a little tricky is counting how many numbers there are. So in this case, let's see, we ended with 23. We started with 3. This is the way I like to think of it. We started with 3, we ended with 23. So that means we added 20 to our original number. We want to know how many terms there are. So we say, well, how big of a step did we take each time? Well, our step, or it's also called the common difference, or D, in this case, is 7 minus 3, or 4. Okay, so our step is 4. So let's see, we went to distance of 20. To get from 3 to 23 is 20. We're doing it 4 at a time. So to see how many steps we took, I think of the steps, we can take the total distance, or the total difference, divided by the size of the step to get 5. So this is the number of steps from the first one to the last one. This does not include the first number. So the number of numbers is going to be 5 plus 1, or 6. I know that may seem like a lot of steps. So getting used to this screen here. There we go. Yep. So just to generalize it, to get the number of steps, you can take the last one minus the first term divided by the common difference and add. That will give you the number of terms. In all of these nums, that's usually these problems. It's usually the trickiest thing to figure out. You can check it with this. Oh, we did it with this one. 23 minus 3 divided by 4 plus 1. Let me just do a bigger example. Separate these. Do 4 plus 7 plus 10 plus 13 plus 16. Another example on that. Let's do So we don't see all the numbers here, but I can see that the common difference from 7 to 4 is 3. So D equals 3. Also know that the first term is 4. The last term is 22. So my common sum is 22 plus 4 is 26. The number of terms is going to be the last term, A sub n, minus the first term, divided by the size of the step, or D, which is 3. And then add 1 to include the first term. So 22 minus 4 is 18. 18 over 3 plus 1. 18 over 3 is 6. Plus 1 is 7. So there's 7 terms. In this case, there's few enough we can check. 10, 13, 16, 19. Those are missing terms. 1, 2, 3, 4, 6, 7. So 7 terms out, but our goal is to get the sum. So our common sum is 26. The number of terms is 7. So our total is going to be 26 times 7 divided by 2. And go ahead and make this smaller to 13 times 7. 77 times 2 is 21. I get 90. That's our total sum. Okay, so to summarize, the sum, which I will notate with S, is an S not 5, is the common sum times the number of terms divided by 2. Divided by 2 because it takes 2 terms to make the common sum. The common sum is the first term plus the last term. The number of terms is the last term minus the first term divided by the common difference plus 1.